All right, this is our next section for chapter 2. It's sections 2, 3, and 2, 4, mathematical modeling and deductive reasoning. So we did inductive reasoning last time, and so we're now going to do a new type of reasoning called deductive reasoning. So let's talk about mathematical models first. So mathematical models are pictures, diagrams, tables, equations, all of that we can use to describe a situation. Okay, and so we're going to have some situations, or so to speak, some type of story problem, word problem that you're going to want to use these mathematical models to help yourself solve it. Some actual physical objects that are mathematical models that we're definitely going to use could be like points, lines, segments, planes. Okay, all those basically terms we talked about in chapter 1, all of those could be represented as physical objects that could be represented as mathematical models. So let's start off with one particular story problem, okay, or word problem. It says each of 30 people at a party shook hands with everyone else. So there's 30 people at this party and everybody shakes hands, okay? How many handshakes were there all together, okay? And I don't think anybody got COVID. So the question is how many total handshakes? So here's how you want to, and here's how I should say students go about it the wrong way. They think of the number 30 and that's it. And then they think, what could they do with 30? Well, we could do 30 squared. We could do 30 times 30 and then subtract the number. And so that's probably what some of y'all are thinking right now, but that's not the way to go about solving this problem. The way you want to go about solving this problem is figuring out maybe if there's some sort of pattern, okay? And you have to start off with very, very small numbers, okay? What if there's only one person at this party, okay? If there's only one person at this party, well, there's no one else to shake hands with, so that means 0 handshakes took place, okay? What if there's 2 people at the party, okay? So me and you. Well, we can only do 1 handshake and that's it, okay? What about if there's 3 people at the party, okay? If there's 3 people at the party, well, think about it. This person shakes hands with this one, those 2, and then those 2. So that means there's going to be 3 handshakes if there's 3 people. Here's one way you could use mathematical models, and I'm going to show you in detail on the next slide. But what if you use points to represent people? And then you use segments to represent the handshakes. So they shake hands, and they shake hands. There it is, 3 handshakes. So then 4 people at the party. How many would there be with 4 people at the party? They shake 1, 2, 3, 4, 5, and 6. So there would be 6. So at this point, guys, you need to start thinking, well, that seems like there's a pattern here. From here to here, it increased by 1. From here to here, it increased by 2. From here to here, it increased by 3. So you should probably figure out what it's going to increase by on the next few, okay? So this will increase by 4, so that means 10 handshakes will go on here. This will increase by 5, that means 15 handshakes will increase here. Then 6, that'll be 21, okay? So the question is how do we use these numbers to get to all the way to 30? Now you can keep going, which is 30 is not too large of a number, okay? But usually there's, you want to find a mathematical model to represent this to where you can figure out and just plug in 30, okay? But if you have, sorry, I thought I lost all my video there for a second. Okay, so we want to think of a mathematical model, meaning like an equation or the nth term, like we talked about last time, to see if we can just plug in a 30. Because if, let's say, there was 200 people at the party and they all shook hands, how many handshakes would go there? Well, you're not gonna keep counting up all the way to 200. That's just too many. So the question is how do we figure out this rule? Okay. Well, what type of rule? this is not linear like the ones last time, okay? It's not increasing by the same amount every time. It increased by 1 here, then by 2, then by 3, then 4, then 5, then 6. So it's not a linear function. It's not constant. But let me show you if you take the second set of differences. If you take the second set of differences, then it becomes constant. So whenever you have a type of relationship like this, then this means it is a quadratic relationship, a quadratic function, okay? And you did quadratics last year in Algebra 1. And so how can we use this quadratic formula, okay, to figure out the rule or the nth term for this particular pattern? So I'm going to let you, if you were in class, we'd use our Inspire to plug in this table and it would make the quadratic regression. But since you do not have a calculator, we found these two sites. This one down here is called Math Power, and that's one site that you can use. And then there's also Math Celebrity. I tend to like this one over here first, so I'm going to go to that one, and then I'll show you this other one. But I'm going to click on the site. I made a tiny URL because it's a really long equation. So, I mean, a website. So let me click on this, and it'll take me there. So it's pretty simple. All you need to do is, and it's free, all you need to do is at this point right here, it says enter 3 points from the quadratic equation. Okay, so right here is where we want to substitute those 3 points. Okay, so I need so the first one was when there was 1 person at the party, there was 0 handshakes. And then on the second one, when there was 2 people at the party, there was 1 handshake. And then on the last one, when there was 3 people at the party, there was 3 handshakes. Okay, and that's it. That's all you have to do. And you're going to want it to calculate the equation, which is, again, remember, like the nth term. And it doesn't show it up here, but if you scroll down, it shows a lot of mathematical information about that relationship. But down here, where it gets to the yellow part, okay, that's your rule right there. Okay, the equation is 0.5x squared minus 0.5x. Okay, so when I go back to over here, I'm going to write 0.5n squared minus 0.5n. Okay, all I did was put n instead of x. And there's your rule. So you can use this to figure out for 30 people. Okay, and you just have to plug it in. Then you can do the same for 200 people. All right, so we'll do that in a second. Let me show you the other website just so you have options. So this one's called mathpower.com, quadratic functions. So when I go to this one, again, I don't really care for this one, but it's pretty easy. So this one, you're going to scroll all the way to the bottom. And right here where it says the points, so you're going to add the points right here. So this one was 1 person at the party. This one was 0 handshakes. 2 people at the party, 1 handshake. 3 at the party, 3 handshakes. And you can actually add a couple more points. 4 people at the party, 6 handshakes. I mean, all you need is at least 3 though, okay? Or 4. So that's all I'm gonna put. Then you just have to click calculate down here. And then again, you have to scroll all the way down. Actually, you don't have to scroll all the way down. It's actually right here. This one shows you the graph, which we don't necessarily need. But right here, here's where your function is, okay? It's 0.5. I think this is why I kind of didn't like it because it has it as a comma. So it's 0.5 times x squared minus 0.5x. So see how it's the same rule, same equation. And so this is that other one. So you get to pick which one you want to use. It'll be saved on here. Okay, so let me show you how to find how many handshakes went on for 30 people. So I'm going to take my rule, okay, my function rule. My function rule is 0.5, and for n, I'm going to plug in 30. And then I'm going to square it minus 0.5 times 30. Okay, and you can use your calculator to do that. And so 30 squared is 900. Half of 900 is 0.5 times 900 is 450. Minus 0.5 times 30 is, we're minusing 15. Half of 30 is 15. So 450 minus 15 is 435, right? So 435 handshakes would go on at a party of 30 people, okay? And then you can do the same for 200, okay? You're gonna do 0.5 times 200 squared minus 0.5 times 200. So 200 squared is 40,000. Half of 40,000 is 20,000. And then half of 200 is 100. So when you minus that, that's 19,900. So if there were 200 people at a party and everybody shook hands, that means there were 19,900 handshakes. Okay, so but the main thing is you want to use one of these websites to help you find the quadratic regression or the quadratic equation. So again, this is the part that you're going to have to really look at right here. You have to determine if it's quadratic. Okay, if it's linear, it's pretty easy. So how would you do it without the calculator? You would definitely want to use the mathematical models, okay, where you can let points represent the people, and you know the segments represent the handshakes, like I said earlier. So we're going to let n represent the number of people. So this is n equals 1, 2, 3, 4, and 5. So n is 1 because we want to figure out what n is, right? And so let's talk about the handshakes. So they shook hands, they shook hands. All of these people shook hands using the segments, okay? So the question is, well, when you thought about just do 30 times 30, right? 30 people times 30 handshakes, that's a good idea. So it's basically based off of, which is what's part of the equation. So it's based off of how many handshakes does each person do, okay? Well, this person did 1. Let me get a different color. This person did 1 handshake, this person did 1 handshake, okay? However, only 1 handshake took place. When we add 1 plus 1, okay, if we add that, we get 2, okay, which is not the same as that. But let's just carry on and discover this pattern. This person did 2 handshakes, this person did 2 handshakes, this person did 2 handshakes. Remember, it's like doing however many handshakes for each person. So all of these people did that. That's a total of 6 handshakes. However, only 3 handshakes took place. Okay, this person did 3 handshakes. They did each 3, they did 3, and they did 3, which is a total of 12. However, there was only 6 handshakes that took place. This person did 4 handshakes, 4 handshakes. Each person did 4 handshakes individually. That's one way to look at it. And so then we times that by 5, right? And so 4 times 5 is 20 handshakes. However, there was only 10 handshakes that went through. So how are these related? Let me highlight that. How are these numbers related? This one to these. They look very similar, right? Okay, they're all half, right? So now the question is how do we come up with this rule? So now you have to compare these numbers to the value of n, because that's what's going to be applied into the rule. So how is n related to, how is n related to that number? How is n related to that number? By the way, there was here 0 handshakes here. How is n related to that number and that number? How is n related to that number. Okay, so how do we look at that? Well, to figure out, oh, also, how is n related to the handshakes? So 3 to the 2, so that one, and to that one. So we have to come up with a number for this. So all of the handshakes, you'll notice, are 1 less than n. So we're going to take that number, n minus 1, right? Because 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 3 is, 4 minus 1 is 3. 5 minus 1 is 4. You see how it comes together like that, right? And so then we're going to multiply that times however many people there are. Okay, well, there's n amount of people, right? So we're going to multiply it by that. So that's fine, but then remember that gave us this number here. What do we have to do to that number to get our real number of handshakes? We had to take half of that, right? So we're going to divide by 2. So we take the number of people right here. We times it by n minus 1 because remember there was 1 less handshake for each person. See all those 2's? Let me highlight those in pink so you can see that. So 1 and 1. Notice that's less than 2. 2, each person did 2 handshakes. Notice that's less than 3. This one did 3. Notice 3 is less than 4 by 1. So all of these numbers that I highlighted in pink, these were the amount of handshakes each person did, which was 1 less. And I know that's a common thought process at the beginning where like, oh, I have to subtract 1 because I cannot include that handshake. So, because we already shook hands. So that's the thing. You can't count this twice because yes, it belongs to this handshake. Yes, it belongs to them, their handshake. But you only want to count 1 handshake. So then you're probably saying, well, this rule does not look like the one we just came up with. Remember the one we came up with was n squared minus 0.5n? Well, if you reduce this, it's the same thing as that. Do the distributive property. So then you get n squared minus n divided by 2, which the same way to do that is n squared over 2 minus n over 2. Put a little 1 in front of the n. Do you see where the 1/2 appears? Okay, so both of these rules, okay, this one right here, that I just put a green star next to, and this one right here mean the same exact thing, okay? But anyways, it's a little bit more complicated, a little bit more thinking when you're doing this by hand. So that's why we're allowing you to use the calculator. All right, let's try it one more time. Let's try it one more time. So we have this pattern. It's clearly not going up by the same amount. It's not going up by the same amount. This one increased by 5, and then it increased by 7. So it's not linear. It's not a constant increase. So the best thing I can think of is these two are odd, right? Okay, so then the next one must be a 9, and then the next one must be 11, and the next one must be 13. So 9 plus 16 is 25. 11 plus 25 is 36. And then 49. Okay, so there's my pattern. Now, if I do the second set of differences, we know that it's not linear. If I do the second set of differences, it goes up by 2, 2, and 2. So remember I said, when you have both of these, you have to now know that this is a quadratic function. It's a quadratic relationship. Once you figure that out, you can use one of these 2 sites, okay? So first point is 1, 4, 2, 9, 3, 16. So I'm going to remember that. I want to plug it into this calculator here. Okay, so the first one was, I already forgot. Okay, 1, 4, 2, 9. 1, 4, and 2, 9. So let me scroll down. So 1, comma 4. Where is the comma on this? It doesn't seem like it is. To go back. 1, comma 4. 2, comma 9. And then 3, comma 16, right? Okay, so now I've got my 3 points entered. All I have to do is click calculate equation. Scroll down to the bright yellow box. There it is right there. There's my rule right there. X squared plus 2x plus 1. X squared plus 2x plus 1. So now I'm going to go back to my rule right here. That's what's going to go in this box right here. So remember we had said x squared. So we're going to say n squared plus 2n plus 1. That's your nth term. That's your function rule. Okay. And that's it. That's the nth term. So you get to use these little calculators from these websites. Okay. So write it down on your paper. Okay. Deductive reasoning. What type of reasoning is that? This is when it's the process of showing that certain statements follow logically from proven facts. That's the main thing here. Proven facts. So you have to have proof here. Basically, you're reasoning in an orderly way to convince yourself or someone else that your conclusion is valid, okay, or true. So in this one, it's a little bit different. We're actually going to try to show proof that in our reasoning ways, we're showing proof that this is the answer. When inductive reasoning, we didn't necessarily show proof. It was just a generalization, okay? So if you look back at the notes, it was a generalization. So here's a way that you show proof, okay? This is using algebra. It says use deductive reasoning to solve the algebraic problem. Anytime you're doing algebra, you have step-by-step rules that you have to follow, and that gets you the answer, x, right? So let me show you how to use deductive reasoning. So your first step is to distribute. So we're going to write 10x minus 24 plus 16 equals 4x plus 2. Okay. Well, that right there, we have to write a reason for. Why were we allowed to write this next step? Well, there's this thing called the distributive property. That's our reason that we used. Okay. So we use the distributive property. The next step, I would probably combine those like terms. Okay, and you don't really want to do two steps in one. You have to do one step at a time, unfortunately. So 10x minus 8 equals 4x plus 2. So what's our reason on why we can write that? Well, there's a math rule called combining like terms. So you just have to write combine like terms. That's our reason why we were allowed to write this. The next thing that I would do is I would subtract 4x from both sides. So when I subtract 4x, this is what I get. I get 6x minus 8 equals, that cancels, 2. So what's our reasoning for that? We did the subtraction method, okay? So you can just write subtraction rule, okay? The subtraction rule is in algebra, if we subtract from one side of the equation, then we have to do it on the other, okay? The next step that I would do is I would add 8 to both sides. So that'll get me 6x equals 10. What's our ruling on that one? We added this time. So this is the addition rule or property, however you want to say it, rule or property. And then our last step is to divide by 6. So our final answer or final line would be 5/3. And what did we do on that one? We divided. So this one's the division property, okay, or the division rule. However you want to write it. Subtraction property, addition property, or rule. I'll actually write it here so you can see that they kind of mean the same thing. Because if we divide from one side of the equation, we have to divide from the other side. That's the rule you learned back in Algebra 1. Okay, so then there's our answer right there, guys. Okay, how do we know it's the answer? We have proof every step of the way. We use the correct rules and reasoning over here off to the right to get our final answer. Okay, so that's deductive reasoning, showing proof. So this I think I wrote for you on your notes. This is just a way to see the difference. Inductive reasoning is used to make conjectures. Okay, so inductive reasoning is used to make conjectures. Deductive reasoning is used to verify the conjectures, to show proof. Real world example, lawyers. Lawyers are the main ones that often use deductive reasoning, okay? Because they have to show proof, they have to show evidence when they're trying to prove something in their case. In algebra, what we just did, we have to provide a reason for each step in the process of solving equation. You have to do the correct steps, of course. Okay, let's do this one last investigation, okay, about deductive reasoning. So it says in each segment, AB is congruent to CD. So AB is congruent to CD. AB to CD. Here's another one, same thing. AB to CD. All right, so we have that. And there's a bunch of points that are collinear. So step one over here, it says from the markings in each diagram, determine the length of AC and BD. What do you notice? AC and BD. So here's AC. In this case over here, it's 100. And then I need BD. BD goes from there to there. Well, those are congruent, 75 to 100. Ah, same thing over here, right? So this one is 36. 36 plus is 116. And then BD, 80, 116. Okay, so these came out to be the same. All right, what do you notice? They're the same, they're equal. I just wrote it down. How do the lengths of AC and BD compare? I just answered that. They're the same. AC is equal to BD. So I'm going to write that down here. AC is equal to BD, or you can write congruency, same thing. So it says use deductive reasoning to prove AC will always be equal to BD. Okay, so AC is equal to BD. So how do you write it out? Well, remember AB plus BC is equal to AC. All right, AB plus BC is equal to AC. And then over here, BC plus CD is equal to BD. So let's write a few numbers here. AB was 25, BC was 75. What does that equal? 100. Over here, BC was 75, CD was 25. What does that equal? 100. Okay. There's proof right there, guys. When you write out the numbers 25 and 75, that's it. Simple as that. That's the proof you need to show. So what is the conjecture here? So it says if AD has points A, B, C, and D in that order, and AB is congruent to CD, so you have to have that right there. Then what came out congruent? We just figured it out up here, that AC must be equal to BC. I'm sorry, I wrote that wrong. Let me fix that. Actually, I'll just scratch it out. Sorry. BD. Let's just write it a little bit. BD. Okay. All right, let's do one more last deductive reasoning. So it says triangle DGT is isosceles. So I'm going to go ahead and draw that right away. Triangle DGT is isosceles. TD is equal to DG. So T must be here, D up here, and G down here. These two are equal. It says the perimeter is 756. GT is 240. Then what is the measure of DG? DG is right here. I'm going to put a question mark there. What type of reasoning do you do when you're solving this problem? Okay, well, remember these two sides are equal, so we can represent these sides to be x and x because we have to show proof of our answer. So when we're working with perimeter, you know to add all three sides. So x plus x is 2x plus the 240 equals 756. I'm going to minus the 240 from both sides. That's the subtraction property or rule. That cancels, so then I get 2x equals 516. Then I'm going to divide by 2, and I get x equals, how many times is that? 250, and then so 258. So x equals 258, okay? And this is the, not subtraction, this one was the division property. So it only took 2 simple steps to have proof. I did the subtraction property, I did the division property correctly, hopefully, and therefore the DG is 258 centimeters. And I have proof. When you have proof, what type of reasoning is that? That's deductive reasoning. Okay, and that's it.